Our first problem will be on computing the average value of a function. So this problem will focus on average values, but it will also do some integrals of trig functions, as you see here. So the first thing to notice is our domain, and this is our function. So the definition for average value I will call f_av. This is going to be 1 over pi minus 0. In this case, we integrate from 0 to pi x sine x cosine x dx. So you see here we have 1 over our right endpoint, which is pi, minus our left endpoint, which is 0. You see here, these are our endpoints. And then f of x, the function, goes here. Integral, we're going to have to do some integration by parts. To set up integration by parts, we're going to need to choose what we use for u and dv. I'm going to choose u is equal to x, and so du is equal to dx. Now the reason I choose that is because I know that the du, it turns out nicely. Now my next choice is dv is equal to sine x cosine x dx. Now the reason I have to choose these two together is because the way integration by parts works is that you need this to be equal to u dv, which is what we have here, so we're good. Now the reason I choose dv to be this is that this is actually the derivative of a function. It's the derivative of the function v is equal to 1/2 sine squared x. Now you can see that. We can check our work. Always a good idea to check your work. We see that dv, so this is our check. We need that dv is equal to d by dx of 1/2 sine squared x dx by the rules for differentials. So this is 1/2, and then we bring down a 2 times sine x, and then times the derivative of sine x, which is cosine x dx. These things cancel, and we get exactly what we wanted. This is equal to dv above. Okay, so now we're ready to do our integration by parts. So if we remember what these are, we know that our integral is going to be given by uv minus integral v du. So in this case we have uv, which is going to be x times 1/2 sine squared x minus the integral of v du, which is just integral of 1/2 sine squared x dx. And remember now we're going to integrate this from 0 to pi. So wherever we're going to evaluate all of this, and then we'll plug in our 0 and pi at the end. Okay. So we already have this first part, so we have x over 2 sine squared x. Now the way we work with this term is we use our trig identity, which is that sine squared x is equal to 1 minus cosine 2x. So we have this 1/2 out front, and then we have the integral. The trig identity says this is equal to 1/2 1 minus cosine 2x dx. And again, this is all going to be from, we're going to plug in 0 and pi at the end. Okay, so we have x over 2 sine squared x minus, now I'm going to bring this 1/2 out, and so we have minus 1/4, and then when we integrate 1, we just end up with x. If we integrate minus cosine 2x, or if we integrate minus cosine 2x, now the integral of cosine x is sine x. So minus cosine x can be minus sine x, but we're going to have a minus 1/2 on the outside, sine of 2x, all from 0 to pi. Now, the reason this 1/2 is here is you can check it again. We check our work, and we take the derivative of 1/2 sine, with the derivative of 1/2 sine 2x. Now this is just going to be 1/2 times 2 cosine 2x, right? This gives us our cosine 2x that we wanted. Okay. So now we're going to work with this stuff, and we're just going to plug in our pi and our 0. It looks like at some point we lost our 1 over pi on the outside, so let's put that back in. So we have 1 over pi, and then we have pi over 2 sine squared of pi minus 1/4, and this is pi minus 1/2 sine 2 pi. So that's all of the first stuff, and then we're going to subtract the stuff at 0. But this one just becomes minus 0 times sine of 0. So all of this stuff is equal to 0. And then over here we get minus negative 1/4, so we're going to get a plus 1/4. And this is just going to be, we're going to be plugging in our 0 here for x. So we have 0 minus 1/2 sine of 2 times 0, but of course that's also 0. So all we have left is this stuff. Now we can simplify this a little bit. We notice that we have a pi here, and we have a pi, oh, we don't actually quite. Let's simplify this a little bit. We have, the first term becomes, well, what is sine of pi? If we try to think about what sine of pi is, this is our unit circle. Pi is over here. Sine is the y coordinate, so sine pi is equal to 0. Sine of 2 pi is over here. That's also equal to 0. So these terms are both 0. And the only term that remains is this one. So we have 1 over pi times minus 1 over 4 times pi. So we have equals 1 over pi times minus pi over 4, and of course this is just equal to minus 1 over 4. So this is our final answer. And remember to box it.